Alright, so it looks like I'm live. Let me close my window. Why I come from live streaming and keeping the window open because I like the cool breeze, but I'm not, so that's very fun. Anyway, today I'm going to be starting a major refactor on my compiler. A lot of it has to do with the abstract syntax tree being an absolute mess of just entangled classes, if guards, all that garbage that you really do not want. There's some stuff, especially relating to indexing arrays, that I really do not like. Like, it is just laughably bad because the stuff that's supposed to be with arrays is not with arrays. It's with the index operator, which doesn't make any sense because the index operator is basically just supposed to be like, oh hey, whatever type I'm indexing, run that type's index function, right? That's all it's supposed to do. That's it. So yeah, it's a bit of an issue, right? So there's also a couple other issues. Adding syntax is painful. A lot of expressions do have a specific order in which they need to be done, and so you use order of operations, a shunting yard algorithm. The easiest way to do it, as far as I know at least. I mean, there's a Wikipedia article on it, had some pseudocode, basically just rewrote that pseudocode in Python. So, easiest way to do it. But not every operation that returns an expression uses it, right? So that's pretty garbage, all things considered. There's also a couple things, like the Lexer has a couple too many responsibilities. Like, what I have it doing is just to speed up parsing, and this roughly worked because at first I had to loop through all of the I forgot what I'm saying. All of the Lexer tokens anyway, right? So why not take that time? Is my mic actually being shit? The fuck? Okay. Oh, I see. It's peaking really hard. Is that any better? Or is that just quiet? Actually, now I'm thinking about it, I think I have some... is it... filters? Oh, no, that's not even the right thing. There's filters here. I think I want to turn some of them off. Is that any better? Is it peaking or anything? Thanks for telling me, by the way. I appreciate it. Otherwise, the whole stream would have been terrible. Crazy, did you just leave? God, you're probably texting me on Discord, aren't you? Oh, you're not! That's surprising. Okay, I guess I'll click the button. Oh my god, that's awful. I am so sorry. I'm just gonna redo this stream. Oh my god, that was bad. That is ultimately just awful. Oh, my microphone settings got reset. What microphone is it using? Is it using this one or this one? I wonder. But yeah, no, that's terrible. What do I select? Maybe that's better. Maybe. Right? I don't know if that's any better. So I turned it down, which I remember that kind of fixed some of the issues, but doesn't feel like it's killing my ears. So I turn this up just a little, right? So talking kind of at a normal speaking level. That's not terrible. All right, I can live with that. Okay, what was I talking about? Right. I think I was saying not every expression is done through the shunting yard algorithm. So you manually have to go through and do the order, and it's just this painful, painful process. And I was actually getting close to getting references and array indexing to be, shunted, I guess if that's the right word. And I gave them a spot in the order of operations. The only issue is I hadn't noticed it at the time. It was actually getting kind of late, so I was being dumb. Um, I put for what was it? References, right? So I was trying to reference an array, okay? Um, and then use it as a type, but it was not being like it was not the correct type at all. It was doing the reference operator first, and I was like, why? It's lower on the order of operations. The array index is supposed to happen first. By the way, I made it so all expression nodes have an as type reference, and by default, this will just say, no, what the hell are you doing? So, I mean, that's good, but for things like types, for things like type names, those are turned into variables by the parser. The parser is like, yeah, that's probably a variable. I don't recognize this symbol, so probably a variable. We'll deal with it later. And the AST is the thing that has to deal with it later. So I decided that when a name has to be used as a type, we should still turn it into a variable, because otherwise just really bad complex parsing rules had to happen. And they were like really, really bad and hard to understand and not maintainable at all. This as type reference is a lot easier. Removed a lot of if logic and whatnot that I had before. I even, in the AST types here, this base one, it has an as type reference. So that way I didn't have to check, is a type being passed in, or is an AST node being passed in? I could run the method on both would work, and I don't have to have branching logic in every single spot, because regardless of what it is, it will still do the intended function. So I don't care, right? And I think that was a good change because it removed a lot of complicated parsing logic, removed some logic from the AST that definitely needed to be gotten rid of, but I need more changes than that. I should probably tell you where I had gotten. So there's a lot of debug. There's so much debug. Yeah, there's a lot of debug. As you can see, this is me trying to mess with this yesterday. I just have a bunch of like random test strings being printed out. I think I've got a screenshot instead. I was working on errors a little bit yesterday. So yeah, I was saying, did I ever? Yeah, wait, I was talking about had the operand in the wrong place. Forgot saying that. Anyway, right, and I was saying why. I really bad at paying attention and focusing. Sorry. So the reason that the operand being in the wrong place was so bad was because if it was on the left, it's gonna. How do I explain? Okay. So like let's say you have 9 plus 8 times 2, right? 8 times 2 happens first, but the parser is going to see 9 plus 8, and that's going to turn into an expression, and then it's going to see an expression times 2, right? So it's like, okay, well then turn that into an expression. So now you have this whole thing is kind of a nested set of expressions that becomes like kind of like this or something, right? If I were to kind of represent it almost like functions, then it's going to... The parser is going to generate this, and this is unshunted, and we want it to be shunted. And what does that entail? Basically, doing a bunch of fancy stuff with the shunting yard algorithm, and eventually it will produce expression 9 plus expression 8 times 2. Right? And you notice that basically all that happened was this 8 moved, and this went inside of this. And the only reason that expression there kind of moved from one to the other was because they share this operand, basically. Right? You can physically see that. 8 times 2 and 9 plus 8. They share that 8. Or am I saying I don't think is it operand that I'm wanting to say, or I don't think it's operand. Um I don't know what the word is, but they share that 8 as common. But because I had it as the wrong one, I had it on the left, which would mean it's never gonna share it. It's not gonna work. So big issue, and so I have it doing that for the not operator as well, the logical not like invert the bits. And I gotta figure out, like, I definitely want to add that as an operator. There's so many operators that need to be added, but I just haven't because I'm having a bit of a skill issue. If I do this refactor, I will probably add a bunch of missing features. Might be able to actually get imports in, because one of the big things preventing imports is there's no real name lookups that are module specific. There's nothing like that. And there's no global list of modules, nothing that I can look into. It's not going to work. So, what do I do? All right, so first off, I need to have some kind of shared state to do that lookup. Now, this is single-threaded, which is good. But if I want to, let's say, multi-thread, and for a language like Python, that might be a really good idea. My parsing times are pretty good, especially considering Python, or at least in my opinion. Like I'm a little bit impressed with it at least. Like parsing times of 0. Oh, sorry, that's 3 thousandths of a second. Oh my god. So that's for I don't know. That's less than 100 lines though. So 3 thousandths of a second. That's not bad. A lot of the time, it's taken up by module imports and actual compilation, like turning it into a binary into object files. That's pretty slow, especially because that has to reach out to your hard drive. That's pretty slow. I'm running on like an 11-year-old hard drive, so my benchmarks are probably pretty bad. And I can't really make lexing go faster. To be honest with you, it's not a thing I can do. So I just don't worry about it because it's just using regex, and it's just like I can't make regex go faster. Not in Python at least, unless I find another Python regex library written in C or something, or Rust that's super blazingly fast. So yeah. Oh, sorry, that's 3 thousandths a second for the module creation. Sorry, no, that's 1/100th of a second, or 1.5 hundredths of a second. That's more reasonable. There we go. Alright, I can't read. So, I don't know. I need to be able to do lookups. So, like I was saying, global state. I keep getting sidetracked. Global state. And the issue is that's probably... I only want to instantiate it once. That's dumb. For a lot of reasons. Like for a module, I'm going to probably create a ton of modules. Cool, right? But, yeah, I'm going to have a bit of an issue because I'm not going to create multiple programs. And when you import another module, it's basically just going to run another parser. And that can be multi-threaded or whatever, and when it's done parsing, then that can be single-threaded. and that'll work just fine. And I can have maybe like actual locks or something, like thread locks, and that'd be fine. I don't mind much with using thread locks, especially when you have what are they called? The with statement in Python. I forgot what they're called. Resource managers or something. I can't remember. You have those, and they basically will most of the time prevent any thread locking from happening. And it's not like the user can't be like, "Huh, this is weird. It's just suddenly stuck," and then they wait 40 days or something, and like, "Oh no, it's been stuck for 40 days. What am I gonna do?" They'll probably stop it if it takes too long and just start another process, and likely won't encounter the issue again. It's probably a freak accident. So I'm not too worried about using thread locks. Honestly, I don't give a shit. Uh, but like I said, I need some kind of global state, and that is going to be a singleton. I don't want a singleton, right? Pretty dumb. Uh, and the way I know you're supposed to not use a singleton is to use a module, because it basically does the same thing in Python. It basically gives you a singleton. Which is good in this case. And it's not that instantiating a second program would be bad. It's that it's pointless and really stupid. So I don't want to. Um, Simple as that. It's just fucking dumb. So, okay. Let's see. Alright, now that we're here, I'm going to stop rambling. I'm going to show you some of the pain and suffering I've been going on. So, I decided I've got this nodes.py thing here, right? And this contains the most basic nodes. So this contained AST node, which is a class, container node, which is another class, which inherits from expression node, which inherits from AST node. An expression node is also a class. So the inheritance is kind of loose here because it really works like a protocol. And that's kind of how I want my language's kind of, what do you call it? Polymorphism to work, right? It's going to be similar to duck typing, or interfaces, where there's an agreed upon way that something works, and if you have a definition for how that agreement works, the compiler will check any type that you try to pass in, that you're trying to say, I know this struct here implements these methods, and the compiler will be like, yeah, that checks out, you can use it like this. And if you want, you can cast it to another type, but it will throw an error if you're wrong. So you can't just go willy-nilly and do stupid stuff, and that's the hope. Right, so it's duck typing mixed with interfaces, kind of mixed with Rust traits, I guess. It's a very simple idea in practice. Implementation, I don't know. I've never seen anyone do it. And the biggest difference here is with traits and interfaces, you define that you are using. You declare that you are using them. You say, I am implementing this, or I am basically you say, I am implementing this interface, or I am implementing this trait. I do not want that. Duck typing, it's like, well, as long as it fits this arbitrary description, we're good to go. Now, Python takes this to a bit of an extreme, and it's all done at runtime, so it's really just you get runtime errors. That's just pain, really. I don't want runtime errors. So, define a protocol. That's the hope. That's going to be pain. I think I'm going to need to do... There's going to be a lot of refactoring that needs to be done. Basically, my current code base cannot sustain anything new that I really want to add, and so I basically have to redo everything. Like, a lot of the expression nodes should be using the order of operations, but they're not, for whatever reason. So, I need to change that. Otherwise, writing my parser is going to remain super difficult. Now, will it slow things down? Technically, probably yes. Do I care that much if it means I can actually maintain my code? God, no. This is way faster than I thought it would be for a shitty toy language, or it's not really a toy language, a shitty compiled language made in Python. I'm very happy with the progress I've made. And I think I can maintain that speed given a refactor, or maintain the amount of speed ups that I've made, but there may be some extra slowdowns, right? So refactoring may cause further slowdowns. So I'm gonna need to deal with those, right? The speed ups will remain the same, but now there's extra stuff that it's doing, so those speed ups aren't as effective because it's getting caught up on other things, if that makes sense. In any case, I'm moving all of these, all these classes. These are just a collection of classes in one file. That is really ugly, and scrolling, I mean, who wants to do that? I want to be able to see the whole thing, one picture, good to go, right? I can't do that here. So, what I'm going to do is I'm moving this to a package, which just makes sense. Why did I not move it to a package before? I don't know. I didn't even think about it until, like, earlier this morning. So, that's what I'm going to do. So I've got these moved. I'm not going to worry about imports for now. I've installed a code formatter, or sorry, a code whatever the hell you want to call it, and that's what I'm going to do. So I'm also in this module class. So this itself is an AST node, and it's so ugly. Be honest. And then here I want to do some fancy things here. And when I say fancy things, it's not fancy at all. It's the complete opposite of fancy. I basically want to take, where is it? Oh, right, it's out here, which just feels weird. I want to take this really big old piece of garbage, probably make it into an object, probably called, I don't know, some, like, IO handler. I don't know. All it's going to do is be responsible for printing errors and warnings and all of that in whatever format you like. Actually, I might even move this into a... So, remember how I was talking about that program singleton? I may move it into that. Now, it's not actually going to be a singleton, don't worry. It's going to be what's not technically a singleton. Because again, it's not technically, but I really hate that I really just do not like the fact that every like code guru is like, don't use singleton, and I'm like, okay, that's fair. No way to enforce it. Could break things if it's not enforced, so don't do it. There's a lot of issues with the singleton pattern. It just feels like, why are you creating an object? Fine, I agree. But then why are we basically going to remake the singleton in a completely different way? Oh, it's not a class this time, though, so don't worry. You're using a module. It's fine. It's not like everything in Python is an object. Like a function is an object with a call method, and that call method's an object that has its own call method, and it's like, everything's a fucking object in Python. You've just made a different kind of object. Sure, though, I guess. I mean, it's an enforceable kind of singleton. The language will enforce it, so fine. But don't pretend it's not a goddamn singleton. I don't know. It just feels like it's the exact same thing. It is a singleton. You just don't want to call it that because it sounds bad. Right? I don't know. Maybe that's just me. Maybe I'm misunderstanding what a singleton is, but I don't know. Another update I might make if I, rewrite this garbage is, oh, I'm also going to be rewriting so many bad doc comments. Is I might add locale files, if that's what you call them. Like English and whatever other language. I don't know any other languages. I'm like doing Duolingo Spanish lessons. I've got like a 130-day streak, but that doesn't mean I know Spanish. Right, so that's very far from it. I took 3 years of the fucking thing, and I probably couldn't make a very coherent sentence. So, it's not like I can actually do any localization, not even for languages that are closer to me. Not that the United States is very small, so it's not like I'm very close to any bordering countries, but whatever, I don't know. I can't actually do localization, but I'm probably going to add, if I do add a locale file, or like, like a language file, you get my point. then I'll probably add options in the command line to add your own locales and load those as the default. So yeah. Alright, let's get started. So expression, nope. Alright, we're not doing anything with that yet. We're basically just laying things out. So there's also a block. We're also going to be using PEP8 naming, and I absolutely hate PEP8 naming. Because look at this, variable assignment, all lowercase, one word. What absolute criminal comes up with that? Sorry, that is unbelievably criminal. I just don't like it. This type thing, is this actually doing that? Did I really? That's not an expression. That's definitely not an expression. There's so many issues. I'm also on a different branch, by the way. It's just local. Depending on how many changes I make and how many commits I need to do, I may make it an upstream branch as well. So keep a lookout for that. Okay. This is absolutely garbage. This is really bad. That is terrible. I don't think I've ever seen anything so bad. So I'm gonna put a to do here. To do gross. Alright. And I've got this little to do's thing here. And in here I can see every to do that I've made. There's actually a lot of these. This actually isn't that unreadable. I actually don't hate this, so Control X. And that needs 2 spaces. Also, notice how there's 414 problems. I'm also going to try to add more typing information. The only issue... Actually, there's a lot of issues, so I'm not going to say the only. Okay, another thing is I think what I want to do is in my Lexer, right? For additional information, where is it? Oh, my Lexer's down here. See what I mean? Can't find anything. At least I'll be able to collapse these when this is all said and done. It won't be perfect, but I can collapse all the different things. I don't have to view everything all at once and be lost as to which files I'm opening and which ones I'm not. Like, I don't close these tabs, one of the reasons being I can't find anything when looking over here, so I have to keep the tab open or I'm not going to find it for 20 minutes. Alright, in here, oh my gosh. Or no, this is moved to parser base. Parser base also has some really gross stuff in it, like that is terrible. Okay. Like this compile function. What this compile function does, and it provides like a 22% speed up, is usually when checking a rule, right? And so a rule in the parser is a string that says how tokens should be laid out. And if it's laid out how the rule says, then the function checking it returns true. Cool? So it's at a specific cursor position. Basically, my parser works as one big feed tape, right? So it goes from one token to the next, matches a rule, and then goes back to the last start token that, or start position that it had. So it'll be like, okay, well, I need to start at the beginning, but sometimes it can make an optimization by being like, well, I know that I should continue to start from here until I finish whatever, and then I start back from the next position that I know is correct. That's how that works. And that works fine. That provides a minor speed up, and that's fine most of the time. Most. It does provide some speed up. It's really hard to read. Anyway, it goes at the position, and then when it sees a check, the check will be like, okay, so I want to start at this cursor position, ahead, behind, it doesn't matter. You want to start somewhere relative to the current cursor position. And then it'll take the tokens that it needs. So it'll be like, okay, from this token to this token, I want to check these. And so it takes a parser rule and basically parses it. It says, okay, so split it by space and then check for these symbols. And so when checking for the symbols, that's how it should. So the parser rule, certain symbols dictate how it should check the tokens. Right, so like a dollar sign is, sorry, a dollar sign is going to say, all right, match the contents, not the name of the token, right? So instead of just matching for keyword, you may want to match for dollar sign define, right? And that's pretty useful. So yeah, I mean, that's how that works, but it has to do a bunch of branching logic, like this. And it does its same branching logic every time. And it does the same checks every time. And it uses those checks to determine how it should do the next checks. Well, instead, we can compile the rule once we get there, and then just say, if we already have the compiled version, then don't do the branching logic again. That would be fucking stupid. We know how the branching logic is going to go. So basically, it generates almost like a lambda, but not really. Basically, it just adds this input variable as a local variable. And, you ever use the IDLE for Python? And, you can just type in some code and it'll print out the output. That's exactly what that does. And we capture that, and that was true or false. That's how it works. But, as you see, it's kind of painful to read. It may be useful to break this up a little more. I might do that. There's a lot of use of slots, and I like slots. They're faster, a lot better memory usage, because I'm already using 50 megabytes of memory. 50 megabytes! That's a ridiculous amount, okay? Now, again, a lot of that is actually LLVM, but I'm not even taking into account maybe another 38 megabytes. So it's using 88 megs for this. One of those being, the 38 megabytes is an import that I cannot control, and so I do not want to include it in the calculation for what my compiler is doing, because it's not really a measure of the compiler. It's not a measure I care about because I can't control it. It's just simply a measure that doesn't matter to me in any significant way. So I ignore it, because it's not like I can do anything about it. I'd like to really only measure the stuff I can control and be able to optimize for. Not that I've done that in a while. So what is this? Missing multiple white space. So I actually quite enjoy multiple white space when it lines up. I added that to the contributing rules, but I may have to revoke that. I mean, I don't even know why I added contributing rules. I mean, like, look at how garbage this is. Anyway, what was I talking about? Source position. I want this to include a string or a file. I am going to make this a named tuple. This is something I should have done so long ago, and I haven't. Why haven't I? I don't know. So, do I really want to add this here? Because, no, this could cause a lot of issues adding it here. I need to think of a place to add this. But I will, okay? So, to do make into named tuple. That will happen. Basically, this, though, that's going to be the file. And so when I add multiple modules, I can, look at that file and actually do things with it. Now I don't have to pass the whole module object all around because I don't want to be doing that. Now, I'm not sure if passing the string is any better, but I don't think it's passing the string by value. I think it's passing it by reference, so it should be fine. If not, I may be able to create a wrapper around it or something. I don't know. It's not going to be modified. Or it's putting it in a tuple is going to prevent modification. Even if I pass it around. Now, actually, if it's passed around by reference, it won't prevent modification. Now I'm thinking about it. Oh, my back. Okay. This is garbage. This is garbage. This is very bad. Double space. I'm actually starting to like them a little bit more. I had to use them a lot, so I've added a pull request to LLVM Lite, and they had some style guidelines, and their code looks good. I don't understand a lot of it because I'm not, super fluent in C types, but their code looks good. It looks like if I took the time to understand and read it, I could probably figure out what's going on. My code is... I can't work with my own code. That should tell you something. I'm sorry. I'm like ranting about how bad my code is instead of trying to fix it. So let me stop doing that. I should be able to... Yep. So that works, right? Yes. This node types, I don't care about it. I don't want it there. It's cringe. These node types, I mean, these shouldn't even be in subclasses, right? It's not, they shouldn't be there. Oh, wait. You know what? I wonder if making AST node... Oh, but it's not. It's not a protocol. I thought I turned it into a protocol. I didn't. Doesn't make any sense, but okay. I need a place for types. Okay, so I'm gonna create a new file, and I'm just gonna call it common types.py. This is a poorly named file that contains important types such as a source position named tuple. So I don't have a good name for this file. If anyone's got a good name, I mean, throw it at me. So let's see. We're going to want a class, and we're going to, call it source position. And this should be a capital S. And this is going to be a named tuple. Okay, so in here, it's going to have a line, and that's going to be an int. And then it's going to have a column, int, and then it's going to have a length, which is also an int. And that's useful for a variety of reasons. And then we're also going to have source name, right? So that's the name of the source file. So we are going to do this from typing import name tuple. I think that's what I want. I can check in Standard functions isn't really even part of the AST. I'm going to be extremely honest. This isn't 100% a part of the AST. It declares no AST nodes. All it does is declare functions. Operations are part of the AST node just because they are AST nodes that are, well, they're instantiated with functions, if that makes sense. Which I really like the solution I came up with here, which is to use these decorators. It's going to have to change. I think I'm going to need to declare these a little differently from now on. This is one of the reasons I've been avoiding making changes, is because I need a place to declare functions that I can access globally, right? And I can't do, so I need that because of the decorators. And I like the decorators. They work exactly as you'd expect. I mean, there's a lot of space and all that, but overall, they're pretty nice. Which I think you're supposed to go like this, but I didn't. So I'm gonna do that. Oops. You're supposed to have double spacing. Which is supposed to help with readability. I mean, in the case of this many functions, is it really doing that? No. Why are these? Too many blank lines. Right, okay. Is this what? Too many. Well, I had that actually for a reason, but. Alright. I liked the way that looked, was why. And. There. Okay. Look at that. So that makes this a little less angry. It's slightly less angry. So, there's a lot here. So for nodes, I'm going to need a new, and then I want parentheses dot pi, and this is, I guess I'm going to keep the name parenth block, but it's a pretty garbage name. So, and I'm not going to worry about how these files interact with each other until afterwards. I want them to be in their correct places, exactly how they're supposed to be organized. I don't really want to worry about, oh, I actually changed it, and then I have to go and do it 80 bajillion times. I will modify where the imports are. I will modify the names as needed. I'll put to-dos and whatnot if there's a name change. The idea, though, is that there should be very little to do. Like, instead of, this is nodes.py, now it's now it's package, and this is going to import everything, so it's going to be fine. So it's going to go, from dot AST node import all. Right? That's weird. I don't know why it does that. So this is no longer AST node, this is going to be block. This is going to be container. This is going to be expression. This is going to be parentheses. There's going to be one more that isn't created yet, and this is going to be key value pair. Okay, so it looks like it does this alphabetically, which I actually do appreciate. So in here, we're going to have a new file. It's going to be key value pair.py. And this last thing for nodes.py, so I'm going to take this, Control X, and I'm going to murder. Where did I just put it? I was just talking about how it was so much more organized. I can find things, and I immediately lost it. There we go. This is going to have that multi-white space warning. I don't know how no one's clued into this yet, though, that you can have these lined up imports. And I can understand why. I don't know. It just seems weird. I really like this syntax, but no one, like every formatter that I found, has just said, no, what the heck are you doing? And I can't use it because of that. So, I have to remove this. I really like when they line up, but apparently no. All the formatters out there say nah, so. Okay, and node types. I don't think I've really used node types at all. And because of refactors that I made in the past, I don't need to use them. I can just do an is instance of expression node, and that will be fine. But I don't for some reason, because I don't know. I do wish, though, that Python had, like, x is instance of, or sorry, in Java it's just instance of. I actually like that that's an operator in Java. That's one of the reasons that the is operator in my language probably isn't going to check for, are these objects the same? If anything, you could probably just say, like, if the reference to x is equal to a reference to y, and then it'll just check, are they the same in memory? If they are, you've got the same goddamn object. Right? And how often is it that you're trying to check for, am I looking at this exact thing? You know, it's not common where you're trying to see, are x and y the exact same object? Like, I've done that once. One time. Never again. So, kind of pointless. And I don't even think I use the is operator to do that. So the is operator in my language is basically going to act like is instance of in Java. You know, x is I32. Is x and I32? Yeah, sure. And then it'll be good to go. And that's only useful when you take into account that, you know, the protocol duck typing feature. And for typecasting, I'm just using like x as like F32 or something if you wanted to cast to an F32, and yeah, simple. So that's how I'm doing that. Remove duplicate. Yeah, so this is a duplicate. I don't need this. I will remove this once I figure out where validate type is used. Okay, so we have all these nodes. And I'm just going to keep this for now so I know what's in here, right? That's all I need it for, is to know what is inside of here. Module, for now, this is fine. I don't have much I can do with this, so I won't do anything with this. Common types. Why is this having a skill issue? Oh, there's no that at the end of the file. So I'm going to use this source position thing pretty often. So this is, yeah, from this, right? So all of these in here are going to need to import this. So let's make that change. Oh, I see. Okay. Right. That solves one issue. AST types. I am renaming AST types. This was a bad name. Completely bad name. I think I couldn't name it types, and that was the issue. But I did not rename it because the name AST types was used all over my code. And I couldn't do anything about it. So I'm going to rename it. And this is going to... I'll save that change. I'll save that change. Once I've moved everything, I'll put classes moved individual files. And then I'll put in, parentheses non-functioning. And then I'll say this has been moved. And then I'll make a commit. And then I'll make another commit where I start adding, all the moved around things. So there'll also be some other changes in there, but I haven't figured them out yet. So for repr, I hate this. It's pretty garbage. This is a really bad repr method. I'm gonna be very honest, and I think I really should. See, look at all that excess white space, bloating up the file size. That's really what you gotta worry about. So generic node, what is that? Right, I think that was like a type alias that I kind of used. This is just garbage. This is useless. I'm getting rid of that, right? That is utter trash to me. These are fine. They're not that big of a deal. Okay. Ref here. That deals with more than variable. That is more than just variables. References work on everything that you can get a pointer to. And you can get a pointer to every expression node with very little exception. Every single node will be able to create a temporary variable if you reference it. Or if you index it, and it needs to be a variable, because you have to do get element pointer, and that's to a location in memory, and it has to be allocated on the stack for you to actually be able to access anything with memory. It's weird. Just don't worry about it too much, okay? It has to be in memory somewhere. And this is also useful for, you want to create variables for all of the arguments in a function. You want those to be mutable. Or at least I do. So you want those to be mutable. So, you could have, like, add x and y as a function. Both of them are ints, and then you say x equals x plus y. That'll still work regardless of your first argument being called x. Which is fine, right? You won't get a really awful error. So, good stuff, right? But like I'm saying, this is a bad spot. References are actually relatively simple. It's basically just a little get pointer thing, but I have it as its own AST node, which is reminding me, I'm gonna fix this. You notice this garbage? These don't need to be in here at all. That's a bad spot for them. They should be where they were before. I do an import. That's what should happen. I added a CLS property. Right? Change the class up. It's good stuff. So the class that creates the nodes after it's done shunting can be changed. That's what matters, right? Okay, so source, going to have a new file called reference.py. And that's not where I wanted that. I actually wanted that in AST, and I put it in the wrong thing. So, move. There we go. So this goes here. Source position, we can... Whoa, no, that's not good. Expression node. Oh, it's not gonna... It's actually gonna have a huge skill issue. That's fine. We can fix that later. Node types. So names. Names don't need to exist. They don't. These do not need names. Actually, yeah, now I'm thinking about it, everything that has a name should have its name removed. I mean, that's as simple as that. None of these should be compared by name. There are so many issues. Now, that name thing did cause me to make a good change, and I think it's a good change because it stops unforeseen errors from creeping through. Errors that really only happen in languages like Python that are dynamically typed. That's, I accidentally passed the wrong type around, and it has the .name attribute that I need, so I take that, and I get the wrong name because, you know, I could be looking for the name of a variable, but that was the name of a function. That's not good. So, you know, functions have .func name, and variables have var underscore name. So, you know, that's a good change. Like, actually good. So, I mean, you don't need to worry about that at least, right? Yeah, nah. Names are for fools. Is operator? Is fine. I mean, that's kind of like a global attribute that's needed for shunting yard algorithm. So that can stay. I've realized that I wasn't setting the other things as operators before. Or I'm not sure I was. I think it was acting as operators because it had a parent class, but yeah. Okay. Loops. This is bad. This should be in a folder called loops. Actually, I'm almost wondering if I should have flow control be a package. So, yeah, flow control. And this is going to, you know, it's a package, so it needs an init, which is, yeah, that's good. And this is going to have one of them for loops, or yeah, for loop.py, and this is going to have a class in it, and that is here. They should also probably have almost a shared class or a protocol or something called, like, what would I call it? I'm trying to think, actually. What do I want to call it? I forgot my train. I lost my train of thought. But basically, it would be like a parent class almost that says, all right, these two share the ability to be, you know, for continue and break statements to work, and this is how they'll work. This is what they expect, etc., etc. Which for two things probably isn't that big of a deal, but it does explicitly state what it's looking for. It removes a lot of magic that would be there. I don't want that kind of magic, mystical, whatever. I want it to be explicitly stated that, hey, this is how this should work. This is why these are named this way. So keep that in mind, and then developers will actually know what's going on instead of just being like, well, why the fuck are we accessing something we don't know if it exists or not? Which is a problem in a lot of this code, is there are so many things where we don't know if they exist, but we assume they do. Because I can understand that they do, unless I haven't looked at my code in a month. In which case, I'm clueless too. That's what happens every time. I take a 1 month break, and then I come back, and it's garbage. So, alright. New file. This is a while loop. These don't need to exist. There doesn't need to be a statement type. That's stupid. Here. Like, how many times? None. I don't use .type ever. I never use .type. I mean, I should tell you something. This is so poorly named. That is missing an E. Why is that missing an E? Right? Like, I don't know. Why is it named that way? That's so arbitrary. Why am I abbreviating? Why am I abbreviating by one letter in the word before? Or I guess two letters. Apparently I just don't like the letter E. Doesn't make sense. Alright, like that's really, really stupid. Why is it like that? This also has the name of while loop. Look at these uncaught bugs. What is this? As you can see, that, I mean, I'm just changing it so the evidence isn't there that that even happens. That's for my sake. Make me feel better. Right, okay, so now we're going to have a new file. This is going to be break statement.py. What do you guess this is going to contain? Oh yeah, a break statement. Why was it so badly organized? Like, it's actually making me mad how bad this code was when the solution was separate things. You'll be able to at least know what component you're looking at. I've made so many dumb mistakes where I've modified the wrong class because they're all listed in the same file. I'll at least be able to see each thing individually. And once I'm going to do more than just organize the files a little. I'm probably going to redo a lot of the type system again because it doesn't support anything that I had planned for it to support. I put a lot of effort into getting the type system working, and it doesn't. And a lot of the reason that it doesn't is because the expression system is really bad. And expressions don't work like how you'd think expressions would work. One of the biggest reasons is expressions are fucking lies. Right? So, I mean, this is just like making me actually just a little mad. Okay, so generic node is this. Okay. And we put these in quotes because we can't use them otherwise. God, I love circular imports in Python. So you literally cannot do anything about it a lot of the time. At all. I'm going to go out of my way to root out circular imports in my language. Now, that really only works because I'm doing a compiled language, and I can guarantee that things aren't circular. Like, I don't have to do, import things on the fly. No, no, no. That's not happening at runtime. So I should be fine. Okay. This is... There is so much pain and suffering happening in these files. Like, look, that is a long line. That's ridiculous. How many characters is that? 183. How did I even manage to do that? I know most of it's comment, but wow, that is impressive. I think it's just impressive how bad it is. This is in loops.py, so I'm modifying the dumbest file. Okay, break statement. It's got a break statement. Wow. It's perfect, right? So, what else? We're going to need a continue statement. So, continue statement.py. Take loops. And Control X. So continue statement here, and boop. Remove these. We don't need these. I think there's actually a couple places where I hadn't done that yet, which like right there and right there. Where else? Okay, that reminds me. So I was working on one of these things. Where did it go? So let me just mess around. So for loops has this going on, and I like the way this looks personally. My formatter says no, 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 and I don't agree. Just on a personal level here, I think that's the formatter being a little cringe. But who am I to judge? right? So let's see. Oh, extra white space. That's not fun. There's a lot of extra white space. That's not something that was on purpose or that I could. I mean, I can probably control it. I just, I don't know how. It's just kind of like a VS Code thing. Um, I am probably gonna use Azure or something and have auto running checks. I despise using Azure for debugging builds on OSs I wasn't running when I was working on the LLVM pull request thing. But in terms of formatting, that was actually a really good idea. Like a ridiculously good idea. And using it for builds is good, except for the fact that, like, I don't know how to do that on here. Like, I don't know if I could set that up in the exact same way they have. And Azure is free, to my knowledge, for people with open source projects. So, I mean, I'm good to go, right? Okay. This is a lot. Okay, what I need to do is open up variable again. Now, struct, this is fine, right? Relatively speaking. I should have a struct package, and it should have struct def or struct definition .py or whatever, and this is in it. That's all. Now, this is actually a really, really simple class. This is ugly. This is extraordinarily ugly. This is a check to see if something's already in use. I think I can make this a function. And I think it should be a function. And I think it should be name is already in use. And it should throw out an error. And if I can consolidate errors like this that are going to be used everywhere. Like, I don't want a type name to be the same name as a function, right? So both of them should kind of perform the same check. Is this name used? So, I mean, yeah. Okay, let's see. Go to variable and index reference. So this is just a terrible doc comment. And what does this do? This is how you index arrays. This is an array index. That's really bad. Like, that's laughable, right? Like, oh my, this shouldn't be a class at all. Truly, this should not be a class. This is an operator pretending to be a class. It does have some extra checks. Very cool, but those checks could be done in a singular function. Just fine. Oh god, not to mention, this file. This is gross. This is a grody file right here. There's like 20,000 code smells in this whole goddamn project. Variable. So, index ref. This should not be named like this. At all. And this, I mean, there's two things dealing with arrays. I am going to put both of them in a, what do you call it? I'm basically going to make them math expressions instead, because that's what they are. They take two inputs, and they do an operation. It's fine, right? Let me make sure the word operand is the one I want. Operand meaning. So yeah, alright. Operand. It says the quantity on what. Yeah, look at that. And there's a little diagram. I was right. Operators and operands. Alright, game remove. I was right earlier. It's got two operands. The thing to be indexed and the index. That's a math expression. It's just not, you know, instead of one character between it, it's a couple. Like, who cares? Right? That's definitely math expansion. So, you know, what I should, I'm not gonna get into doing that right now, right? I'm not gonna be an idiot. I'm not gonna do that. That's a bad idea. Um, Instead, what I should do is just create a temporary package. I'm gonna call this arrays. I'm gonna put in a new init.py and a new file, and this is going to be array index.py. That's all that's gonna be, and this should be renamed, but I'm just gonna put a to-do rename and make to math expression. Good. Okay. This type system is pretty bad. Like, in all honesty, this is bad. There's a lot of these defaults, right, which is fine. I mean, relatively speaking, it's fine that these defaults exist. Like, that's not the issue. It's just it's a very difficult to read file, and things have been shoved in there in random spots, and this is something I tend to do, is I don't really pay attention to how things are ordered in the code, right? Like idiv, imul, isub, that could have a completely different order than sub, sumul, etc. And that would be fine with me when it really shouldn't be. Like they should at least, it should at least try to look good, right? But I don't follow style guidelines when I know I should. I just don't. So I want to change that. So that's what I hope to do when I modify this. There's also going to be a lot more in here. A lot. And the interfacing between a lot of these things is going to be more unified. It isn't going to be specific to any individual type. Like, I kind of got started on that with all these functions, and that would actually, easily lead into operator overloading. It's cool, right? That's one of the reasons I did it this way, is to make operator overloading just exceedingly easy, but I hadn't wrapped my head around every intricate little detail yet, so it's not 100% to that point. I think I need to, I think I can do line space equals space, and then just put line equals. There we go. That looks a little better. These are going to be longer than the line count I want. These, my opinion, which, I mean, if you take my previous opinions here, maybe take it with a grain of salt. These should all be on their own line, despite the fact that it lengthens the file. And I think some of these should be given explanation. Maybe not necessarily through dot comment, because then it feels like all the functions should have dot comments. But like imul and isub, the I stands for in place. But if you didn't know that, then what do you think that's supposed to stand for? All right, it's abbreviated because it's common in the case of operator overloading, but that's not the best excuse. Oh my God, this should not be here, right? I don't think this is ever used, but it's impossible to tell. There is, I don't think, any way I can statically tell. I would just have to wait for a runtime error to occur, if it were necessary. So you see so much commented out code. Because I don't know. One of the issues with Python that really pisses me off. This should be this should be like a global attribute. Self.members. That should be everywhere. So yeah. I wonder if it is. I don't think it is. Oh, and then there's extra white space here. So do this. And then there's this. There's a lot of additional white space. Now, I think I just put an error somewhere. I don't know where yet. So I've got to find it. Got to go on a wild goose chase. Here we go. This is not the best. It is technically faster. And speed is something I do have to consider. And it's not, I can't just be like, oh, but clean code. You know, it's a compiler. It should be able to run on machines that need to do compilation. And that doesn't mean every machine is good. That just means it's like Optiplex 990 or like a shitty ass laptop. Not every computer is, you know, not, you get my point, right? Like, it could be the most garbage refurb office computer or like a 2004 laptop. I need to think about reducing the amount of cycles on the CPU and keeping things fast. Make sure I don't overwhelm hardware or anything. I don't want to do a bunch of branching logic or anything like that. Because I feel like regardless of what I do, it's probably going to have pretty high CPU usage. And so if I can minimize the amount of time that CPU is used for and keep the same amount of usage, then that's probably a good thing. Plus, you know, speed. It's very fun. Name. Now for types, these are compared by name. Should they be? I don't know. I'm gonna be honest. I really do not know. I think yes, but I don't know, right? I'm gonna say yes for now, but do not quote me on that, okay? All right. Let's take. Where is it? There's interface. This is something I was working on. I don't care about this. This actually got pushed. I don't care that this file exists. Honestly, I'm gonna put a to-do here. To-do remove or finish. So I don't think it's gonna let me have to-dos at the beginning of files. I think it's gonna say no. So I'll put that there, right? Because I never ended up using this, and I think I should in some roundabout way or another. The functionality inside of this create this create args dict. This creates a dictionary of command line arguments, starts at the default, and then modifies that default based on what the user has inputted as the command line argument, which is fine. And that's just so I could make sure, like, I didn't have to check if a command line argument existed. I could just check against the default. And if, you know, it was a flag, like, you know, dash dash emit binary, where it either exists or it doesn't, then I could just have that as a boolean, and the default is false. Just don't emit a binary. That's obvious. I don't have any other need. You know, it's either there's, and so that's a boolean value. Wow, crazy. I mean, this works for me. I don't think this behavior should be here. This is bad. Because what if you're trying to make a project and, you know, same things don't apply. But you want the same functionality of creating, you know, an argument dictionary. So what do? You don't rewrite this whole function and you don't import it because that's a really dumb import to make. You should consolidate that into its own module that both things import from, because they're both using a utility. I mean, it's not specific to either of them. That's a mistake I've made a lot where things are like cross importing, and so I'm getting recently a lot of circular import errors. They're the dumbest ones possible because I just have not planned out the project structure very well. I keep adding, 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 and not thinking. I keep doing that. I'm too excited to, I'm like trigger happy with adding features, but I don't think about how they should be added. I just like, I kind of got an idea of how I should do this. Struggle for like 3 hours, and then I get it, and I don't come back to it. I do not refactor. That's just the thing. It's terrible. It's the worst possible programming practices. I'm kind of learning the hard way not to do that. You're not supposed to learn the hard way not to do that. You're supposed to take other people's advice, but I think maybe other developers don't learn the hard way, but I feel like every developer at some point in their life has been like, God, this code sucked. Yeah, either I'm abandoning this project or I'm refactoring. Now, I'm pretty committed to this project, so I'm cool with a refactor. Because I actually really enjoy writing this compiler. I don't know why. It's really satisfying to add features and seeing it all come together, and I can use it to do, I can write more code with the thing that I just wrote code for, so, and I like writing code, so it's, I don't know, it's like a win for me. So this is a statement, and I actually think it should go with variables just because of what it is. And that is a set operation. That's what it is. Now I'm thinking about it. What I should do is for variable assignment, I should consolidate the two functions. That's because overall they're doing the same thing. Now at first they weren't, because not every node had not every single node had the ability to have a pointer. They all now do. The only issue I see with this is the code this would enable, right? If I open up current.bcl, the code this would enable, it would be pretty bad. It would be really bad. This would enable you to do 10 equals 12. Now, you will never be able to access this variable. Ever. Not a single time. Now, this is easily remedied by a check in the parser. But what about, I don't know, member access, where I have, like, you see up here this, and I have x.x.y equals 12. What then? Right? I mean, what? I don't know, right? So, I think this is the only time where the names and the node type things have been useful, is in cases like this, where I almost want a group of types. The only issue is this kind of causes some unintended consequences. What I think I should really do is I should give every expression node a global property. All right, hold on. I should give every node a global property called assignable, or not a property. It's more like a flag, really. So every node has an assignable flag to say, okay, yes, you can assign data to this, and that's a much easier way of doing things. So that's probably what I'll do. Let me write a comment, and I gotta do one thing, and I'll be back. So, let's see. In this, I think what I wanted to do was I wanted to put this here, and then to do consolidate to consolidate functionality into above class. And what else was it? I wanted to right in where is it? Ah, here it is. in here, I want to have assignable equals false. To implement. Okay, I will be right back. Okay? Where's the mute? Alright, I'm back. That's crazy, right? I think I'm gonna send the link to the stream to some people in a Discord server. Oh, never mind. Wait, why is there just a random... Sorry. Okay, so there's a compilers and interpreters thing that I'm in, so... Okay. Sure, I'm not even using that IDE theme anymore. That screenshot is so old. Alright. Time for suffering. There are a number of issues. So I was talking about this assignable flag that I want to have. So I think I definitely want to go this route. Because I think this at least makes sense, is that I can use the expression, an expression as the first... It's almost as if the equal operator is going to... Or I guess it's an assignment operator, but it doesn't work as an expression, so I don't want it to... I don't want it to be shunted, because that would be a bad idea in my opinion. But it is, instead of doing a bunch of rules where we make sure that this thing is a keyword, or we're not doing that. It's stupid. It's going to simplify the parser a lot, because basically the parser is going to accept a lot more things that are invalid but are way easier to catch when you have a constructed AST than if you just have leftover tokens. Catching leftover tokens is... You basically need a separate parser for that. And I don't have that. I've got like a really, really bad error parser. That's got to go. That error parser has to go. I may have a parser to detect, is there a semicolon? If yes, we're good. And I think that's the extent of it. Maybe a couple other common issues, but it's not going to be like it is in its current state. So, and it may even be a completely separate parser. So, that's the hope. This I'm going to keep. Why is this? Oh, 2 spaces before inline comment. Cool. Okay. There's a lot of to-dos. Can I count the number of to-dos? It doesn't look like I can. So, what sucks is I may, like, if I ever decide to bootstrap the language, like if it gets mature enough to do that, then I gotta do this whole process again. Exact same thing. It's gonna suck. Alright. What do I do? So, I want to do that. And when that happens, right, so that assignable flag, because everything, you can get a pointer to everything in my language. You can get a pointer to something that isn't, like, it is a, you could get a pointer to an integer literal. And it will allocate some, memory on the stack. And that integer literal is now stored there. That's how that works. And you get a pointer to that, which very technically would allow you to use that as a variable, I think. So that's fun. It would work just fine. Is it a good idea? Oh God, no. No, definitely not. It's probably some terrible undefined behavior. But do I think it's dumb to disallow it? Yeah. I think it doesn't matter enough, right? Like, if you chose to do that, deal with it, right? Like, there's no way you accidentally do that. Unless something went wrong in constructing the final bytecode, there's no way you accidentally do that. In which case, that's not a you problem, that's a me problem, right? So, I don't know. Okay. There's a lot of to-do items here. Exception. This is really bad. I think this should stay here, but I don't think it should be done in this form. I should have a runtime exception, like printer or creator, or like something similar that does basically what this does, but in a generic way. To do, make better. Oh, and comments. Geez, like comment this. This doesn't even have a doc comment. Block stack. This is global state that should not be there. This is almost similar to like a stack trace, but in a dumb way, right? To do move global state to centralized location. And I think I'm gonna copy that because I think that's just kind of a thing that's gonna be common, right? That's not gonna stop coming up. There's probably a lot of global state that should not be there. So I'm gonna remove it. And not remove it. I kind of need this. This is useful for a lot of reasons. Forget the words I'm looking for. Append nested vars. This works. This should be commented. Like, what am I actually doing here? I'm going into the block stack. I'm going one back, and I'm saying, okay, the parent to this block, I need to grab it and take its variables and put it in here. But like, this is kind of ugly. Like, there's a splat operator or whatever you want to call it. I always forget the name. It's not in a that's not being done in a good way. Okay. Module, this is kind of fine. There's a lot of things, so many unused functions. I should consolidate this. I expected to do things that I'm not actually doing. And for future proofing, it was probably not a bad idea, but because my code is just this monolith, I'm not actually able to use any of this because it requires giant changes to every other part. There's so much coupling going on. Okay, so math. This is actually fine. Maybe this should be in a different place than these, and then, stuff like that. Where maybe separate it into a couple files so I have categories of things, but that's not a necessary change. So that's kind of fine. Functions. That needs to be a package. This is a lot of things. Right? You've got the return statement, you've got a function definition, and you've got function calling. Now, function calling should be consolidated into a function type. Function definitions are going to be kind of necessarily complicated. There's not a lot I can do about that. So, yeah. Some of it can be, made simpler, but a lot of it can't. So I gotta kind of pick and choose where I want to, work that out. So in the AST, I'm going to create a new folder, and this is going to be called functions. Okay, it was given a little fx thing. That's not what it wants. I want a new file, underscore init, underscore dot py, and there's going to be a new, and this is going to be function definition dot py. This, I think, although defining global functions, like not global functions, like standard library functions, is not really a responsibility of the AST. I think this makes the most sense in terms of where to put it. So I'll probably do that. What is in my, okay. No, I don't need that. So in here, oh, what? I'm actually gonna close out of a couple of these. And remember, like, none of this actually works yet, and it's not intended to. I'm moving things, and then I'm going to probably fix imports, uh, and then remove things. And then I'm going to kind of hammer that into everything else I've done and remove things where necessary. It's a long process. Things aren't going to click together immediately. There's probably going to be a long time between, me writing the code and running it, which could cause issues, but I shouldn't be changing that much. I'm changing a lot, but nothing that should completely break how compilation works if I do it successfully. That's something I won't know if I've done or not. And a lot of it's just renaming and moving things, so there won't be too much to debug. So, the root cause of my issue should still be hopefully easy to find. Okay, so there's this function def here, right? But there's also a function object, which I feel, that can be the function type just fine, honestly. So I can probably, so there's this underscore function thing, and then it's got this define internal function. And this is useful, right? That's the thing I can keep. That's useful for defining the standard library. I'm going to keep that. But, it's this, wait, where is it? This is not a replacement for a proper function type. So there's args here. This isn't used. Right, why is this there? So I'm going to put a to-do remove unused. Right, that's unused. Why is it there? That doesn't need to be there. There's a lot of unused. So a lot of gross code here. Okay. So we've got function definition. I need a function call. Now call should be an operator. For now, it's not going to be. So, again, just for now. It will be eventually. And that's gonna be part of this before I ever pull anything in. I'm not pulling anything in until I have a function type. Shunting yard being applied to all operators and stuff like that, because there's so many operators that just do not follow the same standards, which doesn't make any sense. Should follow the same standards. So, alright, let's see. I need function call .py, and in here I'm going to put a to-do should be turned into an operator and use a function type. So we take not this, we want this, and so that's the return statement. Here's the function call. Take this, Control X, Control V. Okay. So that does what you'd expect. Something I have been forgetting to do. Comment these out. Those names, they're just using memory that isn't necessary. Alright, I realized there is an assign operator. That the assign works similarly to an operator. In the fact that for any given type, it can determine how it does its assignments. And that's useful for like if you have an I8, but you put in a number which by, you're setting it equal to like, let's say 12, but 12 is always going to be by default instantiated as an integer, an I32. So, having default conversions for assignment is fine. So it also is pretty helpful when talking about references because I want them to be automatically dereferenced. I don't want pointer math to be a thing, and realistically, they're useful in the fact that you can modify state across functions. Right? Like, state can exist in one function that's modified by another function. And you also don't have to do a copy. That's another good thing, is you do not do a copy of the memory. You pass the same thing in. So that's, it's fine. You're not supposed to mutate state or whatever in functions. You gotta have those pure functions, but yeah, no, that's not always true. So, alright, return statement. This is actually an easy one, I think. So, I don't even think the return statement has to do anything. Function definitions don't have to do that much either. They really just gotta change what global state they're modifying to say the function is defined, if that makes any sense. So, and they also have to use the, function type. Okay, new file, return statement.py. I really hate this naming convention, but I want to stick to PEP8, so I guess I gotta do it. Okay, so that's been moved. This needs to go. So I'm gonna put to do remove for real function type. That's what I actually want to do with this. So standard functions. This should be moved, and I think I can just copy this. It's a few hundred lines. It's like, yeah, no, it's less than 200. So inside of functions, I want to have a new file, and I'm going to call this standard functions.py. A lot of things that need renamed. So there's so many things happening here. Okay. Let's see. There is so much happening. This needs to be moved probably, but I really just want to focus on the AST right now. Structs. That, it doesn't have a lot right now, but it does need to be moved. I need to move literals. I think I should actually focus on that right now. So, because that's more stuff. I mean, this isn't that big of a deal right now, so it honestly could probably be ignored, but I don't think I should do that because I've been in the habit of ignoring those things, and now I got to do a whole refactor. So I'm just gonna put this as literals. How do you spell literal? Literals spelling. Okay, I spelled it right. Okay, good to go. So new underscore init.py, and then I'm gonna close all these. Oh wait, oh, I almost made a giant mistake. Oh wait, no, this is, no, that's fine. So take all this and close it. It's not necessary, right now at least. I don't want half of it open. So much. So, let's see. What the hell is happening here? Okay, let's see. So, I'm gonna want new, and I want probably number literal dot py. What would be better? No, cause no, that wouldn't really work a lot of the time, so I can't do that. The parsing on most of these literals is different, so I can't do that, even if I wanted to. I can't really consolidate. So if I go to literals.py, right, I just take this class called literal, and I copy it. Hyperref literals, these don't exist anymore. I don't know of a single instance where this is used. I should actually check. Typeref literal. It imports and doesn't do anything. So, okay, it's not even necessary. This is for type reference. No, that's not even true anymore. So, let's get rid of that. That also isn't technically true anymore. But that is. So, yeah, this is, for all intents and purposes, completely useless. That's being removed. This this number literal, that stays, and then we create a new file, and we call this array literal.py, and we put in an array literal. These are slightly more complicated because arrays have to just be rude about how they exist. So take that and then move it, save. That's fine, right? Array literals, I'm gonna put to do refactor. I don't like this code. There's these if conditions. So I don't want that. Okay. What's next? There is a string literal. Okay, so string literals are weird. I don't actually like the way these are implemented. These are not memory safe. They will actually allow you to do some really, really dumb stuff. I think I made them non-returnable in my last push to the dev branch, but I don't honestly remember. They are actually a stack pointer. And yeah, so I don't want those to be returnable, but I have them acting as if they're not a stack pointer. See the problem there? So let's see. Okay, so I'm gonna make a new file. Whoops, new file in literals, and this is going to be ring literal. That does that. I don't even think I should have a string literal type, in all honesty. I think I should have a string type and a C string type, which can be created from the string type. And you cannot return a C string. Or maybe you should be able to, but the rules on that are just weird. Like, I don't think you should be able to return a C string, but maybe if you return a boxed C string, that's fine because that outlives the stack. Right, so. And that could be accounted for. The box type is kind of like a specialized version of a struct type. Like it, and not really, but it kind of. So, what do I do? All right. Let's see. Alright, so I copied string literal in. Sorry, I got distracted. Range literal is just like this very hyper-specific thing, and eventually there will be a range type. There is not. A range type works almost... Oh, hey. It works almost exactly like a struct type, but it's just slightly different in the fact that it's dumb and stupid. So, let's see. You know what I haven't been doing is getting rid of these name attributes. These, I don't want these anymore. These just use memory for no reason every time. So I'm gonna create, okay, in here, I'm gonna put new file and then range literal.py, move this into its own file, save it, and then what's the next one I need to do? Struct literal. Okay, so this is the last one. This comments can stay for now. I'm gonna put a to-do on there saying like remove them. You don't need commented out code. Just look through the Git history. So okay, literals and then new file, and I want struct literal. Now this doesn't. There are two kinds of struct literal here. This is kind of like instantiating a struct. Uh, and that's the kind I mean, but the other kind could be like, I think Rust has them, where you kind of are referring to a type that doesn't have a name, like they're like struct literals. It's weird, okay? And they're basically like tuples, but they're not tuples. And the members don't have names either, so you do like dot zero, dot one, it's kind of a weird way to do it. Honestly, I think what might have been better is using the index operator. Like, personally, if I add something like that, which might need to be done, um, the index operator is probably the way I'd go. It's personal preference, though. I mean, I could honestly allow for both. There's nothing saying I can't. Shite. Yep. I'm not going to be able to stream for very much longer. Let me do this. I'll add the to-do item. That might be it for me tonight. It's getting kind of late. I've been streaming for 2 hours apparently. I may still work on this outside of the stream, and I'll update you on how it goes. If you want to get updated, there's a Discord server down below. There's the GitHub repo if you'd like to start on GitHub and see all the commits and whatnot. You'll also be able to see those on the Discord. There's a channel that automatically posts all the commits once they're pushed, as well as a couple other things, I think. So like opening and closing issues, new releases, that sort of thing. So I think that's it for me tonight. Let me just add the to-do item. Remove unused code in comments. There we go. So this literals thing is good to be basically like wiped away. So to-do delete. This doesn't need to be there. Basically, we don't really even need to check anything about literals. This name does not matter, because the only time we really do a check for literals is when we're indexing things. So, I mean, who cares, right? There's not too much, like, and that's only for indexing things with like a guaranteed size. Like if you overwrite the index operator, I can't check that statically. I may be able to check some things statically, but not others, and the things I can check statically are usually just arrays. So I really only need that functionality for arrays. So I can just check against one kind of literal, a number literal. But I mean, that's all for now. Like I said, thanks for tuning in. I will continue to work on this. This is probably going to be one of the largest pushes and pulls that I've had to do. It's going to remove a lot of code. It's going to add a lot of code. It's honestly probably going to remain roughly the same line count if all goes according to plan, because I'm going to be removing a ton and I'm going to be adding a ton. Actually, I may end up with more because I'll have to re-add those import statements, but instead of just a one file, it's in every file. That's not that big of a deal. Alright, I will see all you later, another stream maybe. I got some chores to do, and